Hello everyone, in the previous video, we learned about the four classifications of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In this section of the course, we will learn about the overall process of machine learning. Due to the relatively large amount of content in this section, so we might split this machine learning process into two videos to give everyone an overview. I believe that through the study of the previous two sections, many students will have a general framework for machine learning. So this section of study is to reinforce the general framework you have already formed and make up for the missing parts. So the overall process of machine learning, that is, the several parts listed on this film of ours: data collection, data cleaning, feature extraction and selection, model training, testing and evaluation, final deployment and integration. Then we will find that among these middle ones, they have the same color, and there is an arrow indicating it is for feedback iteration. That is to say, data collection, the data we collected initially, is exactly as it is. Finally, the deployment and integration of the model, also related to our final work, our machine learning algorithm. The key focus is on these four central parts: data cleaning, then the selection of features, model training, testing and evaluation. If the result is not good, iterate again. You need to clean the data again, choose some better features again, then train the model again and evaluate until the model you eventually form can meet your requirements, meet the requirements of practical projects. Then your entire machine learning process is considered complete. Finally formed an effective model. So for this lesson, we'll also focus on elaborating on these four intermediate processes. First, let's take a look at the dataset. What is a dataset? A dataset is a set of data used in machine learning tasks. Each piece of data is called a sample, reflecting issues related to the performance or characteristics of the sample, or in other words, attributes are called features. So what is a dataset? The dataset is like the basket we initially obtained, that pile of data. In the data, some of its attributes, we call each attribute a feature. Next is the training set. It is the data set used in the training process. The data we initially received, it is the biggest concept, which is the data set. So our data set needs to be split. The simplest way to segment is part of the training set, part of the test set. The training set is used for training. We just saw that we need to iterate the whole process, right? During the iterative process, iteration after iteration, we are using the training set data to optimize through continuous iteration, continuously optimize the parameters inside our model. What is the test set used for? After learning the model, the process of using it for prediction, call it a test. In other words, during the testing process, need to use data. You always need to put in a piece of data to check. I gave you a piece of data. Can you come up with a correct result? The data set used in this process. Pay attention to the data set used at this time. We call it the test set. At this moment, there is a very crucial question. Can the training set and the test set have intersections? Intersection, attention, this is absolutely not acceptable, absolutely not possible. Intersection is not allowed. The training set is the training set. The test set is the test set. Their data cannot have any intersection. If you use the training data for testing again, then your results will be very good. In this way, your test results will be authentic. Next, let's take a look at an overview of the data. This is the most typical style of a piece of data. One by one, 1, 2, 3, 4, 5. Like this, one by one, the data, I divide the above four data into a training set. The fifth set of data is used separately as the test set. I use the first four pieces of data during my train. When I test, I only use the fifth set of data, no intersection at all. In this piece of data, it may have the area, school district, orientation and final house price, so I might consider area, school district, and orientation as its three features. My goal is to obtain, or rather to predict, the price of a house. So the final house price is its label, and all the properties related to this house. Its area is also good, whether it's the school district or not. No matter which direction, all of these serve as its features. This is a dataset. Its original appearance. All datasets are like this. For supervised learning datasets, it is under the label column. If it is unsupervised, then it has no label. Then you need to use this type of algorithm. Simply learn its features. So we've talked so much about data. Why is data so important? We need to emphasize data in this way. This is reflected in our first sentence. Data is crucial for the model. Please remember this word, crucial. It is the ceiling of model capability. Without good data, there won't be good model. Many of our students may encounter some problems when working on projects. No matter what algorithm I use, no matter what method is used, I always fail to achieve a good result. At that time, it may not have been an issue with your model. It's an issue with your data. In the field of machine learning or artificial intelligence, there is a very popular saying, it's the model you've built or the results you've produced. Just trying to fit the distribution of your data as closely as possible. Fit the distribution of your data as closely as possible. It is impossible to perfectly fit the distribution of your data. You are just fitting as closely as possible. Your data is what determines the outcome of this project, or the key to whether your final model is good or bad. You provided a bunch of bad data, it has a lot of noise, it has a large number of missing values. Then you cannot get a very good result with any model. This is the importance of data. Then the preprocessing of data, in order to improve our initial data, which may not be very good at the beginning, processing it into data that is very suitable for our model. So it is mainly divided into these few parts. Data cleaning, fill in missing values. It is possible that in the process of obtaining this data, some values are missing. So you need to fill in, based on experience, fill in a value of 7 in the middle. Fill in a 6, what other ways will there be? Discover and eliminate the causes of data and abnormal points. What is an outlier? 1, 5, a 7, with a 1 in the middle. So it's a normal person in terms of data. Or to put it another way, it's a normal piece of data. It will be found that there are actually some issues with this place. It might be a noise point, caused such. There is a value of 10,000 like this. So at this point we need to clean the data. What is the other one? Dimensionality reduction of data. Simplify data attributes. Avoid dimension explosion. What does this represent? Just now, everyone can recall the video from the previous section. We have created a small example. We differentiate between men and women. Some of the data dimension, or there are some features of the data. I wrote about a leg and a face. Is there a category for legs? Is it necessary to judge a person based on this kind of data? Especially when our data consists of men and women, I believe that all data may have this item. Legs. At this time, this one-dimensional data, features of this dimension, it is just unnecessary. So we need to reduce its dimensionality. Simplify our data, because it has nothing to do with our results. Avoid dimension explosion at this time. Why avoid it? With each additional feature you have, you need to perform calculations. This is for your calculation loss, or it could be a significant loss to your computing power. Just now we talked about deleting some features. This belongs to low variance feature filtering. Simply delete these low variance features. Sometimes we are using some other methods to reduce dimensions. For example, HCIA dimensionality reduction. It is achieved by integrating certain features, achieve a new feature, then achieve a dimensionality reduction effect. Another data standardization, standardize data to reduce noise and improve the accuracy of the model. Why is it said that standardized data can reduce noise? Let's continue with the example we just used. 5 10,000, 7 7 such a data arrangement. If we knew at this moment, our data will fluctuate around 0 to 10, so it's very simple. I set 0 as 0, I'll just set it to 1, all the data in between, normalize according to this scale, between 0 and 1. I don't care how much noise there is in here, 1,000, 10,000, or even 1,000,000, so you are greater than 10 in the end. I calculate everything based on 1. Can it reduce the impact of noise here? Although this 1,000 here may be a 34, normalize it to 1. There may still be some but at least it's much less impactful than the previous 10,000. So in this way, it can indeed improve the accuracy of our model. Then the workload of data cleaning. Here is a pie chart to show everyone, this is also why. Or to put it another way, this is also what we emphasize here, once a data is very important in the process of building a machine learning model. Data scientists, 3% data reshaping training set, 5% is doing other work, a relatively large 19% collected data set. Collecting datasets is also a very important task. You can form a very good data set. It is a significant contribution to scientific research. Optimize the remaining 4% of the model. Discover patterns in data, accounting for 9% of the content. What is 60% for? It is to clean and organize data. You need to constantly review your data. Is it a very good data set? A large amount of work is spent here. So we see a lot of work spent in the process of data cleaning. What is the main purpose of data cleaning? Mainly did filtering and missing value processing, outlier handling, merge data and data aggregation, data filtering, data missing, data anomalies. We have just been introduced. Right. Mainly to remove some noise, fill in some missing values. What does merging data from multiple sources refer to? Your data may come from more than just this aspect, may come from multiple data sources. You need to merge and summarize it. Summarize the data, form a complete data set. Sometimes your data may represent only a part of the entire data set. So many data sets are needed to form a complete data set, to make your data free of any discrimination, or your data is unbiased data. This is what makes a good data set. This is the work of summarizing and merging data sources. When it comes to data cleaning, the term dirty data must be very common. We often hear such a statement, dirty data. So what is dirty data? Mainly, there are incomplete data quality issues, high noise level. In this case of inconsistency, we refer to this data as dirty data. So here is an example. We can go through them one by one. Indeed, it refers to very typical dirty data. There should have been a value here originally. That's an invalid value. Here, the gender should be male and female only. There is an extra A here. This A has absolutely no idea. Are they aliens? This is an invalid value. Should be in the value of another column. What does this mean here? In Italy, this should be in the country, not in the city. So this value is placed in the wrong position. This is also obviously dirty data. Incorrect spelling. Clearly this is a spelling mistake. It does not exist in any country. No country has this word as its name. There are also attribute dependencies. This is obvious, like this value. It has attribute dependency. These two features exhibit obvious attribute dependencies. This is also incorrect here. Format error. Like this, we humans can understand such data. However, in the field of computer science, usually typically require that a column of attributes all follow the same format. Then you use another format. Humans can understand, but computers cannot understand. And this one, invalid duplicate item. We all know about this ID column. It cannot be duplicated, or you may specify one of your attributes. It is all unique values. You have duplicate items. This is clearly a mistake. Okay, the next topic is data transformation. After this preliminary data preprocessing, after the cleanup work, we need to convert a lot of data into some machine learning model, commonly used expression forms. For example, the first type. In classification problems, we need to perform one-hot encoding on the categories. What is the other code called? Called one-hot encoding. Also known as one-hot encoding. What kind of method does dumb encoding adopt? It's the category. We all know that categories may have 1, 2, 3, 4, or 5 types. But the computer won't recognize this. What do we usually do in this situation? If you want to do 2 types, men of this kind, women of this kind, what is dumb encoding? Being a man means being female is 0, 1. All men are 0, female is 0, 1. What is one-hot encoding? One-hot encoding here. This is one-hot encoding. When it's hot, man is 10. female is 01. In other words, the biggest difference between gray code and 1 hot encoding is the dumb encoding utilizes this 01 hot encoding. How many categories do you have? I have a long string of numbers like 01. Which category do you belong to? I am just in that position. Set 1 3 types of 1 hot encoding. It's just 1 0. This is the way that machine learning models recognize. It is convenient for us to deal with many SOPs functions later. This is the postscript. So the next one, it is to convert numerical data into categorical data. To reduce the corresponding value, we all know about age. We may exist from 0 to 100 years old. But sometimes we don't need to distinguish so finely. We may only need to know the teenager, middle-aged, elderly. That's fine. So I can divide the age range from 0 to 30 into one group. 30 to 60 years old is considered as one group, grouped as 60 to 100 years old. I use the original multi-classification data, become a 3 classification data. This is the transformation of data. Is there anything else? For example, extracting useful data from text data. Bag of words that can be used. Word to vec. You need to spell a word man, woman, China, words like foreign countries. Convert it into data recognizable by a computer. Like word to vec. It's just converting the vocabulary we just used into a series of numbers. Replace our original data with this string of numbers. So when processing image data, various features formed by you, color features, higher features, etc. This converts the original pixels into other features. At this point, this introduces the concept of feature engineering. It is to normalize our original features. Standardization ensures that the codomain of different input variables of the same model is consistent. This is a very important point in feature engineering. The place you used to have is the input word. Some places input numbers. After feature engineering, after the data transformation, we turn it into inputs with the same value range. Features of inputs with the same value range. Sometimes there will be some feature expansion. For example, at the beginning, I only had pixel features of this color. So I regenerated some higher features. Or some other features. Right, this is the expansion of features. Feature selection. We have just done a lot of feature expansion and feature selection. Is there a necessity for this thing? It is very necessary. Usually, in a dataset there are many different features. Sometimes these features may be redundant. Or another, this situation that is unrelated to our predicted value. At this point we need to perform feature selection. It can simplify the model, make the model easier to interpret. It can also avoid the issue of dimension explosion. And it can also reduce training time, right? The amount of data is reduced. So the training time is naturally shorter. And it can enhance the generalization of the model. Methods of feature selection. This photo begins to introduce the method of feature selection. The first method is the filtering method. The overall process of the filtering method is on the left. It traverses all features, then find the features, such a correlation between it and our results. The most important point. The relevance is here. Relevance. Evaluate the relevance of each feature to our target property. Arrange in order of relevance. Retain highly correlated features. Selected the features we need in the end. It is unrelated to the model itself. Its prerequisite is that our features should be unrelated to the model itself. The common method is Pearson correlation coefficient, kappa coefficient, mutual information, and other methods. The limitation of the filtering method is that it tends to select redundant variables. It does not consider the relationships between features. Once one of your features is highly relevant to the target attribute, at the same time, you also have other features that are highly correlated with this one feature. So the results selected using the filtering method is to select all the features in this round. So actually the circle of features you selected, or this type of features, it is still very redundant. This is the filtering method, its approach, and a drawback of its existence. Next is the wrapper method. Wrapper means wrapper.
What is the packaging method like? It regards the entire feature selection as a search problem. It first traverses all features, then generate feature subsets. Then go to see the performance of this feature subset. It is scored based on the accuracy of the model. You have generated many feature subsets. Further scoring based on the accuracy of these feature subsets. Select a subset of features with higher accuracy as the final result. A common method is feature recursive elimination method. Packaging methods also have their limitations. The bagging method is a very computationally intensive method, because it needs to perform a calculation on each subset, so its computational workload is very large. What is another limitation? Its feature selection method is usually specific to the type of model, provided the best performance characteristics. In other words, its specificity is too strong, too specific. This will result in insufficient generalization ability of the entire model. Alright, next let's take a look at the embedded method. Embedding method. The method of embedding is to incorporate feature selection as part of the model construction. How is it done then? Just like the one shown on the left side in this image. It first generates a feature subset, then use learning algorithms to conduct an effectiveness evaluation. If the performance is not good, generate another subset of features. Proceed with another assessment. In other words, embedding the process of our feature selection into the process of building our model. So the most common method is our regularization method. You should still remember L1 regularization and L2 regularization. L1 and L2 regularization are behind our lasso loss function. In addition, with L1 regularization are behind our lasso loss function. In addition, with L1 regularization, just completed the process of feature selection using the embedding method we just discussed. So the most common ones we all know, if linear regression is combined with L1 regularization, it is lasso regression. If combined with L2 regularization, linear regression combined with L2 regularization, it is a ridge regression. Alright, so that's a key point of this section. So in the next section of the video, we will continue to explain the overall process of machine learning algorithms. Okay, thank you.